Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmi Muhammad Asri. My matrix number is 01 DSB 1951026. And today our topic will be energy efficient buildings, a case study. So the particular building that I chose for this topic is the Hearst Tower. So these are the contents of the case study. First, we have the introduction, and then we're going to be talking about the building description of the building, and then we're going to discuss about the thermal comfort, and then we have the passive ventilation, lighting, acoustics, awards received by the building, and suggestions, and lastly the conclusions of the case study. So what are the aim of the case, or the goals that we can have after this case study? So first, we have recognition of green efficient buildings. We are able to identify and recognize green efficient buildings. Secondly, we have advocating sustainable energy into more buildings. I hope to inspire more architects into applying sustainable energy to future buildings. And then thirdly, improvement in environmental health, making the public more subconscious to the environmental health of our environment. Fourth, we have lastly understanding the operation of green efficient buildings, comprehend what it takes to into erecting a green efficient building. So the Hearst Tower. So what is the Hearst Tower? The Hearst Tower is the world headquarters of Hearst Corporation, bringing together, or the first time, there are numerous publications and communication companies under one roof, including, among others, is Cosmopolitan, Esquire, Marie Claire, Harper's Bazaar, Good Housekeeping, and lastly 17. All are well-known businesses and companies that live under one roof of the Hearst Tower Corporation Tower. So here is the timeline of the Hearst Tower. Before the famous high-rise was erected, the original stone facade was designed by William Randolph. So before the Hearst Tower was even built, the base of the tower was actually a stone facade or a stone building that was built by an architect named William Randolph back in 1928. And then in the year 2008, nearly 80 years later, the tower was conceptualized by famous architect Norman Foster. And then 3 years later, being the first skyscraper in New York City, the Hearst Tower was built into existence. And then what are the distinctive features of this particular building? So material wise, the building was constructed using 85% recycled steel and designed to consume 26% less energy than its conventional neighbors. And then we have the facade. The tower has a triangulated form which consists of 4-story diagram. The corners are peeled back between the diagonals, creating an effect to emphasize the tower's vertical proportions and creating a distinctive faceted silhouette. And then we have the ice fall, water sculpture titled Ice Fall, a wide waterfall built with 50 tons of glass which cools and humidifies the lobby air. It circulates filtered rainwater that has been collected from the roof. It's definitely an eye catcher when you step foot into the building. And then lastly, we have the view, a skylight view of the tower rising above, and the huge diagonal structure supports for the tower create a sense of drama and a staggering feel. Next, we're going to talk about the building description. So the building, bit of the background of the building is the architect was by Foster and Partners. The architectural style that this building expressed was a modernist style, and the project designer was Norman Foster. Structural engineer was WSP Contour Senok. Construction was by Turner Constructions. and the project started in 2006. Floor count is 46 floor, and the floor area is 80,000 square meters. So the location of this Hearst Tower is in Midtown Manhattan, New York City, USA, or 300 West 57th Street, or 959 8th Avenue. So about the area is 57th Street is known for a very busy street and is well known as a corporate street. So here we have the site analysis. We have the traffic, transportation, building operation, homes, streets, harbor, river collection, deliveries, miscellaneous, all the sources for the city noise. And then we have the index for air pollution, ozone leak, carbon monoxide, nitrogen dioxide, particulate matter of New York City. So here are the sections and floor plans of the building. As you can see, we have the lobby floor plan, typical plan for the Hearst Tower, side plan, elevation, and the section of the building. So here are the sun direction of the building, and then we have the wind direction of the building. So this is the structural system of the building, a system diagram over here. We have the perimeter diagonal structure. And then we have the node intersection for diagonal ring beam to connect diagonal and edge beam, and then floor slab, service core, ground, and then we have. So now we are going to talk about the thermal comfort of the building. So first we have the ice fall. Perhaps the most important element for thermal comfort is the sculptural piece called Ice Falls. It's a 3-story waterfall that runs from the 3rd floor level to the lobby on the entry level. Originally intended as a sculptural piece, this waterfall affects the flow of heat and air in the system by either humidifying or cooling the air. This occurs by altering the temperature, whether the off steam will want to capture warm air or release it through water's convection properties. So first, or other methods of thermal comfort that exists in this building is the enclosing. Glass material has an E-coating which allows plenty of natural light while keeping radiation cut. Next, the base of the tower is cast stone which naturally helps constant temperatures in the building. Next is the die grid. The die grid frame is assembled to stop thermal bridges, penetration of an insulation layer from occurring. And then we have the columns. The steel columns are sprayed with an insulation, then surrounded with stainless steel sheets. Next, the walls. Heat conductive limestone paves the atrium walls, covering polyethylene tubing that circulates water year-round to help control the ambient temperature of the building. Floors, area where floors, plates or beams are insulated as well. So here are the devices that control the indoor air quality. First we have the air purge cycle, and then we have the CO2 and VO2 sensors, and then we have the humidity sensors and controls which control the humidity of the building. And then we have variable air volume system, and then we have central air handling unit on the 18th floor, temperature control unit on every floor of the building. Heating and cooling systems. Air conditioning equipment is highly efficient with variable speed fans. HVAC's innovations include utilizing spill air from the tower to heat and cool the atrium. Rainwater is used replace water lost through evaporation in the office air conditioning system. A building automation system manufactured by Honeywell manages the environmental systems. So on a material selection point of view, for better thermal comfort, first, the walls are coated with low vapor paint for maximization of thermal comfort, and then the concrete sealant, which has a low toxicity rate, was used on the concrete surfaces. So, and then the selection of furniture such as desks, chairs, and other furniture selections are formaldehyde free. Lastly, uh, floor and ceiling tiles are produced from recycled materials. And then we have ventilation. Let's talk about the ventilation of the building. So, normally, this the Hearst Tower has minimal flow of air because the use of the system called condensation. So they don't need natural air to flow in, because they, in other words, they create their own air to cool the tower. So any form of ventilation that they use for this building is actually just heat, exiting heat from the tower through conduction routes such as fans, convection fans, and etc. So in a nutshell, the system is composed of various parts that control the interior air quality and temperature through the convection and radiation methods, while keeping unwanted exterior air under control by controlling conduction routes. The Hearst Tower, the floors of the third floor atrium spaces also contribute to flow of the heat within the large atrium space. The floors have been constructed in order to provide radiant heat or cooling depending on the seasons or temperature. The system works by running many small pipes underneath custom-made stone floor tiles. The pipes are filled with either hot or chilled water, and thereby radiate the water temperature onto the tiles. Then the warmer or cooler air, again depending on the season, mixes with the fresh air that is forced into the space from the outside by HVAC systems. The water that was gathered by the rain was then humidified and turned into cooled air through the process of condensation. Next, we're going to talk about lighting of the Hearst Tower. The Hearst Tower goal for lighting is to maximize natural lighting to enter the building. Less interior walls are added to further maximize natural light penetration. In the morning and afternoon, the lobby tends to get natural lighting more because of the ice fall sculpture. The ice fall sculpture reflects light from the atrium skylight to distribute into the lobby. In result, efficient lighting is provided throughout the building. Being a very exposed building to sunlight, the difficulties of excessive light penetration is possible. So, in result, light sensors were installed to control the amount of natural light coming in the building. The electric lighting itself is as energy efficient as many commercial projects these days. Most of the floors utilize recessed 17-watt T8 high quality color rendering fluorescent fixtures. On the executive floors, where more art is on display, the fluorescent lamps were used to tandem with the 37-watt halogen downlight. So now we move on to the acoustics of the building. Every office in the Hearst Tower use acoustic ceiling tiles to reduce echoing and any unwanted sound that will disturb the corporate environment. The floor is covered with acoustic carpets as insulating material to minimize vibrations and reverberations. The walls are insulated well with acoustic insulation to block out any sound or vibration. So let's move on to renewable energy. The Hearst Tower recycles rainwater in the three-story wall, which is able to control humidity in the space. The water is used to distribute throughout toilets, taps, and etc. The building uses 30% less water a year uh, compare, compared to other structures. That's the result of low flow fixtures, water conservation, and a rainwater harvesting system that uses non-potable water to clean sidewalks and other outdoor hardscapes. The Hearst Tower has installed 1 million individual solar modules to produce clean, renewable electricity. The total energy consumption of the building is 20% less than any other typical skyscraper, which means they save around 2 million kilowatt hours of electricity per year. So let's talk about the achievement that or awards that the Hearst Tower has won throughout the years. So first we have the Emporis Skyscraper Award, and then we have the LEED Gold for existing building certification, and then the International High Rise Award, and lastly Council on Tall Buildings and Urban Habitat 10-year award. So this is just the tip of the iceberg. They've won many awards. You can't count how many awards they won throughout the year, but these are the few that I collected, that the major awards they won throughout the year. So there are a few suggestions that I would like to make for this tower. Firstly, I would like to add more natural or passive airflow in the building by creating an indoor landscape and open the atrium, allowing the air to flow in naturally. And then my second suggestion for this tower is using solar panels as a renewable energy to supply electricity would increase efficiency. And lastly, the overall design looks like a prison because the unnatural look the building is portraying. I would design it in a more organic way so that it gives out a more welcoming feeling to anyone. And lastly, what can we conclude from this topic today? The Hearst Tower truly lives up to its expectations. It can give other architects ideas on what they should start concentrating on in their work. The truth is that the building is in New York. It should now influence on architects to motivate them to create buildings with new ideas of being green. If all buildings were designed the same, there would be much change in the field of building. I say the building is great. It's a great landmark to all the people to know about the structure of the Hearst Tower and the usage of recycled materials. It is great how buildings can have a great structure and being about the environment. This building is more than just a building. It's more than just a building. It is the future. It is a pathway to a new road for architects. I hope in the future more buildings like the Hearst Tower multiply and change the world for the better. That is all from me today. Thank you.